This video is about scatter graphs, correlation and correlation coefficient. And I'm going to use question 8 from page 381 as a source of data to explain these ideas, which has a table that looks like this. And we're going to do three things with this data. We're going to draw the scatter graph, we're going to describe the correlation, and we're going to find the correlation coefficient. And just before we go to draw the scatter graph, a piece of information about the way the table is usually set up. So generally the top row of the table is going to go on the bottom line of the horizontal line, the horizontal axis of our graph. And this top row of information can sometimes get called the independent variable. And the bottom row of our table is generally going to go along the vertical axis, and it can be called the dependent variable. It's always a good plan before you start just to check what your maximum values are, so you know how far up you're supposed to go. So I can see, for example, that in my paper 1 values here, the highest result is 40, and in my paper 2 values, the highest result is 39. So I'll go about as far as 40 on each of the axes. So I've drawn and scaled my axes. It's also very important not to forget to label the axes. I should also make sure to title my diagram. These elements should be present in every diagram that you draw, and they're easy to remember using the acronym SALT. So SALT, which just stands for scales, which are the gaps that you use on the axes, and obviously here you're numbering them. A stands for axes. L stands for label, so we're labeling this axis and this axis. And T stands for title. So that's just a nice little checklist to run through at the end of any diagram, just to be sure that you have all of those things in to get full marks. Okay, so now I'm going to plot my points on my scatter graph. So I'm going to remember that this axis here is paper 1 and this axis here is paper 2. So for example, my first piece of information here is 27 on paper 1 axis and 30 on the paper 2 axis. So I'll go to 27, which is about here on the paper 1 axis, and then up to 30 on the paper 2 axis. And I mark in my point. I repeat this for all the other points on my table. And at the end of this process, I've got 15 points marked on my scatter graph. So far the things to watch out for are completing your diagram accurately using these criteria here, putting the top line of the table on the horizontal line, horizontal axis of the graph, and putting the bottom line of the table on the vertical axis of the graph. And just make sure then obviously that you're reading from the correct row when you're filling in your points onto your scatter graph. And at this stage you can see why it's called a scatter graph, because the points are scattered in various different locations around the graph. And it doesn't look as regular as graphs that we might draw, such as bar charts or histograms or pie charts. It looks a little bit random. And that's because there may be a relationship between our variables, our paper 1 and paper 2 results, but they don't come in a straight line. And that's what happens then when we go to discuss correlation. So correlation is simply talking about how closely related our different variables are. In this case, our values for paper 1 compared to our values for paper 2. On the most basic level, we can identify correlation visually. If we have all our points creating roughly a line that slopes up, then we've got positive correlation. If the points aren't very tightly clustered along a line, then it's weak correlation. If the points are all quite close to a line that you could draw, then it's called strong correlation. If the points cluster around a line that slopes down, then we'll be talking about negative correlation instead. To summarize the different types of correlation, if our line is sloping up, it's positive correlation. If our line is sloping down, it's negative correlation. If the points on the scatter graph are tightly grouped around a possible line, then it's strong positive. And if they're very loosely grouped, then it's weak positive. And the same then for negative. Points tightly grouped along a possible line, strong negative. and loosely grouped weak negative. Now it's important to stress that there might not be a line as such drawn on the diagram. It's just looking at your diagram and seeing, if I was to draw a line that went close or as close as I could get to most of those points, would those points be tightly grouped around it or loosely grouped around it? I'm going to draw in a rough line into my original scatter graph here just to show you what I'm talking about in this case. But again, oftentimes there won't be a line drawn onto the graph for you. So I tried to draw my line as close as I could to as many of my points as possible. And I can see that my points are fairly tightly grouped around that line. So in this case, the correlation is strong, positive correlation. And it can be helpful, even if you're not asked to draw a line in, to do it yourself to help you make that decision. Next, we're going to look at how to calculate the correlation coefficient. Correlation coefficient relates to how strong or weak our correlation is, and also whether it's positive or negative. The correlation coefficient is called R, and R has a range of possible values from -1 up as far as 1. So R can only ever be between these values. Let's imagine the correlation coefficient range of values as a scale. -1 is perfect negative correlation. So what we would expect to see in a diagram like this is negative correlation where all the points aligned perfectly along a line. And +1 is perfect positive correlation. So again, it would be positive correlation, but all the points would line up perfectly along a line. 0 indicates no correlation. So there's no apparent line that can be drawn between the points at all. This would indicate that there's no relationship between one variable and the other. On both sides of 0, the closer I get to the end of the scale, the stronger my correlation is. So looking on the left-hand side, first of all, for example, -0.3 is quite close to 0 and quite far away from perfect negative. So we could class this as being weak negative correlation. -0.5 is halfway between no correlation and perfect negative correlation. So we could class this as moderate negative correlation. And -0.7 is getting closer to perfect negative correlation, but it's not quite there yet. So we could class this as being strong negative correlation. And it's the exact same on the opposite side of the scale. 0.3 on the positive side can be considered weak positive. 0.5 can be considered moderate positive, and 0.7, getting closer there to the 1, is strong positive. Generally, if you're only given two options between strong and weak, if it's between 0.5 and 0, then you can consider it weak. And if it's between 0.5 and 1 on either side, you can consider it strong. Okay, so that's all fine if we know what the correlation coefficient is. We have to go off and calculate that yet for our particular set of data in this question. So I'm back up here to my original diagram again, and just as importantly, my original table, which I will need to work out my correlation coefficient. And while there's a formula for correlation coefficient, you'll find it isn't even really mentioned in the book because it's quite complicated. We're expected to go straight to our calculator to calculate the correlation coefficient. So on turning on our calculator, the first thing we should do is just clear the memory, just in case there's anything lurking in there. And again, that's the same as before. It's just Shift 9 and then follow the instructions. So initialize all, equals for yes, and AC to confirm. And now the calculator's memory is clear. And at this stage then, I need to instruct the calculator that I want to enter what's called bivariate data. Bivariate data just relates to the idea that I had two sets of data, my paper 1 set of data and my paper 2 set of data. Okay, so to do that on the calculator, and again, this is the newer Casio now, so I'll show you for this one and then I'll put a link up on Teams so that you can see how to do it on the older calculator also. So in this calculator, I'm going to press menu and I'm going to press 2 for stats. Now I've got an option here, option 2, y equals a plus bx. Now you might recognize this is looking very like the equation of a line, and that would actually kind of make sense here because we're talking about how close our points are to a line. So that's the choice I'm going to make. I'm going to choose 2. And when I make that choice, it gives me 2 columns, okay? And the columns that it's giving me are just the top line of my table and the bottom line of my table. And just like before, when I'm entering data, it's really important that as I put it in, I just press equals after every piece of data. So I'm going to start filling in X values, which is just my top line of my data. So I'm going to put in 27, press equals, 36 equals, 34 equals, 23 equals, 24 equals, 30 equals, 40 equals, 25 equals, 35 equals, 20 equals, 15 equals, 35 equals, 34 equals, 23 equals, and 35 equals. And you'll see that when I'm finished, that I've got 15 pieces of data entered, which is correct for my table. And then I'm going to arrow over into my other column. And now in the Y column, starting from position 1, I'm going to start entering my data from the bottom row of my table. So I'm starting there with 30. So 30 equals, and again, equals each time just to register it on the calculator. 27 equals 32, 28, 20, 37, 35, 25, and 33. Once I have it all entered, I'm going to press the AC key. And it looks like I'm after getting rid of all my data, but again, it's being stored inside in the memory of the calculator. On this newer calculator, I'm going to press the option button, and it asks me what I want. And I want option number 3, regression calc. So I'm going to press 3, and then it gives me 3 values. It gives me A, B, and R. A and B aren't relevant to us on the ordinary level course, so we can ignore those. It's just the R that I'm looking at. And in this case, R is 0.87, and there's a good number of decimal places there. I'm just going to give my answer in this case to 3 decimal places. Obviously, keep an eye on the question. They'll instruct you how to round. If they don't instruct you how to round, then it's a good idea to keep 3 or 4 decimal places in your solution. And I get R equals 0.874. Now, just to go back for a moment to my scale for correlation coefficient, 0.874 would be approximately here. And we can see that that's up past 0.7, so it's definitely in the strong positive correlation part of my scale. And this agrees with the determination that I made initially from my diagram, where I could see that my points were all quite tightly clustered around a line that I could draw through them. And so I can tell from my diagram, but also from my calculation for correlation coefficient, what type of correlation I have. And in this case, my calculation for R just confirms my earlier statement that the correlation is strong positive correlation.